Alright, example 11, use the information to evaluate the limits. So we have this piece of information, which tells us the limit of some function f of x as x approaches c is equal to 2. We also have this information, which states the limit of g of x as x approaches c equals 3/4. So let's use those limits to evaluate a, b, c, and d. Okay? So part A, we've got the limit of a constant, which is 4, times the function f of x as x approaches c. So again, when you have a constant multiplied by a function here that you're taking the limit of, you can factor that constant out in front of the limit. So the constant is being multiplied by the limit of f of x as x approaches c. Then we know that this limit here is equal to 2. So I can write 4 times 2, which would be 8. So there's A. Look at B. B, we have the limit of the function f of x plus the function g of x as x approaches c. So another way to think of this, we could rewrite this as the limit of f of x as x approaches c plus the limit of g of x as x approaches c. These, you definitely can break limits apart this way. And then we know that this is equal to 2. And this limit here is equal to 3/4. So 2 plus 3/4 is 2 3/4. Okay, there's part B. Part C, very similar to part B. We can break this up as the limit of f of x as x approaches c times the limit of g of x as x approaches c. So we know the first limit is equal to 2. We know the second limit is equal to 3/4. So if you multiply these together, you're going to get 3/2. Okay, part D. Again, very similar to B and C, but this time we can break this up as the limit of f of x as x approaches c, and then divide that by the limit of g of x as x approaches c, and then we would have 2 divided by 3/4, and then you could multiply the numerator and the denominator by 4, and we would get 8/3. So there is A, B, C, and D.